Hello everyone, today we're going to be talking about the Trimble R10 GNSS receiver and the new RTK positioning technology that it uses. My name is Jay Haskamp. I work for Frontier Precision in our St. Cloud, Minnesota office. I do our technical support as well as being a certified trainer in Trimble GPS and Trimble Robotics. So let's take a little overview look of the R10. You can see there's an updated keypad with an updated on and off button with indicating lights for satellite availability, radio link, as well as the integrated Wi-Fi. There's a new smaller radio antenna, a integrated quick release adapter that screws onto your rover pole to easily attach and detach the R10. There's two LEMO ports on the bottom, one for the RS-232 connection and one for a USB connection. There is an internal SIM card slot for cellular broadband connection for VRS and also for Wi-Fi, as well as a new battery with a power indicator. Simply push the button on the battery and you will get a metered light system that shows you how much power is left in the battery, and then a dual locking battery system, which is a pretty exciting improvement over some previous models. Simply slide the battery into the R10, a lock will lock the battery in place, and then there's also a new weatherproof locking battery door cover which closes down and then locks everything into place. Here's a quick look at the bottom side of the R10. Again, you can see our connection for the quick release pole clamp, as well as the attachment for where the radio antenna will go. And then lastly, you'll see the two LEMO ports. The black LEMO port is the RS-232, the standard LEMO connection, and then the yellow LEMO port is the new LEMO USB connection, which allows USB connections to the computer as well as to a USB thumb drive. Okay, let's take a look at some of the new technology in the Trimble R10, which will allow you to have productivity beyond traditional GNSS. Some of the new technology includes Trimble HD GNSS, Trimble SurePoint, Trimble Xfill technology, Trimble 360, as well as an ergonomic design and a lot of improvements to the R10 receiver itself. If you pair this R10 with Trimble Access and Trimble Business Center, you'll be using the most powerful total solution on the market today. Let's start with Trimble HD GNSS. Trimble HD GNSS is the next generation processing technology for precise GNSS positioning that surpasses the older float-fix technique. Trimble HD GNSS allows you to have precision-based measurements. Your receiver is always initialized, and your measurements and your quality of your measurements are based on precision values outputted at the bottom of the screen. This allows you to start measuring sooner, as well as have shorter occupation times, and allows you to measure with confidence in more challenging environments. The new precision-based measurement technology in the Trimble R10 is a weighted ambiguity resolution technique that surpasses the older float-fix technique in traditional receivers. This provides you more accurate position and error estimates than older GNSS technology. The Trimble R10 outputs a 95% confidence level in your precision values versus the traditional circular error probability measurements that other receivers are using. This allows for reduced convergence times, reduced occupation times when measuring points, increased position and precision reliability, especially in more challenging environments. Down at the bottom of the screen you will see the older Trimble RTK fixed float solution, outputting a RTK fixed, horizontal and vertical precision value, and an RMS estimation. The new Trimble R10 simply has an RTK horizontal and vertical 95% confidence level precision value output, as well as a check mark indicating whether or not you are in tolerance. Looking at the Trimble Access status line when using the Trimble R10, you will see as an output a horizontal precision estimate, a vertical precision estimate, and then an indicator whether or not your precision estimates are within your user-definable tolerance. These tolerances can be set up in your survey style for your different types of point measurements. The default for these tolerances is 15 millimeters horizontally and 20 millimeters vertically. The next technology in the Trimble R10 is the Trimble SurePoint technology. SurePoint is an integrated tilt sensor within the R10 that enables faster measurements, increased accuracy, and greater quality control. The integrated eBubble means that all of your measurement information is in the same place on the screen of your data collector. This guards against erroneous measurements due to tilt in your pole. It allows you to measure faster with automatic point measurement and point storage, and gives the surveyor a new level of traceability in your survey data. Part of the Trimble SurePoint technology is the Trimble eBubble. The Trimble eBubble is an electronic bubble that can be used instead of the traditional pole bubble. Simply press the Control and L keys on the keypad of your data collector to show or hide the eBubble from any screen. The eBubble is aligned to the front LED panel of the Trimble R10. Please take a look at the image to the right. Notice the orientation of the keypad of the Trimble R10 in relationship to the data collector and how the surveyor would hold it. It is critical to have the Trimble R10 keypad facing this direction in order for the level bubble movements on the eBubble screen to correlate with the actual movements of the R10 receiver. The eBubble or the tilt sensor also need to be calibrated within the R10 receiver. This can be easily done with Trimble Access under the Instrument and Receiver Settings menus in the Access software. Simply set the Trimble R10 up on a tripod with a recently calibrated tri-rack to calibrate the eBubble. The eBubble guards against erroneous measurements due to pole tilt. A tilt warning appears if the pole is ever outside of the user-defined tilt tolerance during a measurement or at the start or storage of a point. This can also be disabled in the survey style. The integrated tilt sensor and eBubble also allows the surveyor to auto-measure and auto-store points in the field. Hundreds of points can easily be stored with only one tap of the Start button. The measurement begins when the tilt is within a predefined tolerance, and the point is auto-stored after 2 epochs of data are recorded. Notice at the bottom of the screen the default settings available for the tilt tolerance. We have a 1 centimeter, a 2 centimeter, and a 3 centimeter setting. The integrated tilt sensor also gives you a new level of traceability in your survey data. Surveyors want raw data. The tilt sensor values are stored with every point and can easily be reviewed in Trimble Business Center, a report can be run on it, or the tilt distances can also be viewed in the QC graph in the Trimble Access software. The next technology in the Trimble R10 is the Trimble X-Fill technology. This is powered by the Trimble RTX technology. Trimble X-Fill allows surveyors to continue surveying without interruption when they temporarily lose connection with their base station or their VRS cellular network. This allows for more continuous surveying, less downtime in the field, and allows you to survey for up to 5 minutes without interruption when you lose your base radio signal or your cellular signal. Notice on the right-hand side of the screen, when Trimble X-Fill kicks in, you will get a small radio symbol along with a little clock symbol indicating that you are running on X-Fill. Also on the bottom of the screen, your precision values will be displayed showing that you are surveying an RTK X-Fill. Trimble X-Fill is a new RTX-based technology that leverages a worldwide network of Trimble-owned and operated reference stations. Trimble X-Fill utilizes geostationary satellites. When you lose your connection with your base station or VRS network, Trimble X-Fill uses positional information that is delivered to the R10 via RTX L-band overhead satellites. When you are surveying with Trimble X-Fill, your solution will diverge over time. The specifications for Trimble X-Fill divergence are 1 centimeter per minute for horizontal RTK and 2 centimeters per minute for vertical RTK. You also should know that your base station needs to be located within 1 meter of an actual WGS84 coordinate. Simply using the here key also requires an SBAS corrected position in order for X-Fill to work properly. VRS users should also check with their network operators to make sure that this technology is available to them. This is a map showing the Trimble RTX coverage as of March 2013. Notice the entire United States has the ability to use this technology. The last technology we would like to talk about in the Trimble R10 is the Trimble 360 technology. Trimble 360 is a powerful new tracking technology that is capable of supporting all existing and planned GNSS constellations and augmentation systems. It has an industry-leading 440-channel tracking specification, which means more satellites, which also means you can measure in more places. Future-proof your investment with the Trimble 360 technology. The new Trimble R10 is truly built for the surveyor. A new level of precision engineering, the smallest and lightest GNSS receiver in its class. The Trimble R10 is packed with many new features. It is 40% smaller and 30% lighter than previous Trimble GNSS receivers. It also has a rugged IP67 standard, improved weight distribution, and improved handling means less fatigue after a day in the field. The Trimble R10 is packed with over 30 new features. Some of the communications features include a wideband UHF 2-watt transmitting radio, a UMTS with internal antenna, Bluetooth and Wi-Fi, and a serial and USB connection. The Trimble R10 also has a web UI accessible via a smartphone, a PC, or your data collector right from the field. It can be used as an internet access point. It has 4 gigabytes of internal memory with the ability to download to a thumb drive in the field, as well as a new long-life smart battery. Using Wi-Fi, you can access the web user interface on the Trimble R10 via a smartphone, a laptop PC, or through your data collector. This allows you to field configure your Trimble R10 on the fly and even add radio frequencies to the R10 without having to hook it up to a computer and run WinFlash. The Trimble R10 is connected to the internet via a cellular SIM card. It can also be used as a mobile hotspot and an internet access point. To connect to your R10 through the Wi-Fi, first disconnect your device from any existing Wi-Fi network, then search for all available networks. Locate the Trimble GNSS with the 4-digit number in your list. The 4-digit number represents the last 4 digits of your R10 receiver's serial number. Once connected, open your web browser and enter in the IP address of 192.168.142.1. You will get a screen asking for a username and password. By default, the username is admin, A-D-M-I-N, and the password is password, P-A-S-S-W-O-R-D. These username and password settings can later be changed through the web user interface. The Trimble R10 also has a new internal UHF radio. This internal radio can broadcast at a powerful 2 watts versus the previous 0.5 watts. This will approximately double your radio range and increase your working area by over 400%. The Trimble R10 also has the capability to work with OmniStar. OmniStar provides a real-time differentially corrected position without the need for radio link. This is included in every Trimble R10, but requires an OmniStar subscription. Using the new USB LEMO connection, you can now automatically download your field data to a USB thumb drive. There are also changes to the antenna height measurements. We have bottom of antenna mount, bottom of quick release, and bottom of R10 lever extension. An added benefit of the Trimble R10 is the ability to pack all the accessories, including the chargers, cables, batteries, and anything else into a single case. The new cases are a little bit smaller and lighter than previous cases and also have a cutout for the Trimble data collectors. There is also a charging kit available for the R10, which comes with extra chargers, cables, and batteries in another case. This case can allow for the storage of 2 Trimble R10 receivers and up to 8 batteries in a single case. And that concludes our overview of the Trimble R10. I would like to thank everybody for taking the time to watch this recording. If you would like more information on the new technology, check out the Trimble R10 white papers on our survey blog at www.fpisurvey.com. Simply pick the Choose Your Page menu and Trimble R10 GNSS receiver from the list.